Okay, so I'm going to go through the first mastery test. Good luck. So we're going to get the lower bound for the number of bins needed, we are going to add everything up. So 1 add 5 add 10 add 1 add 5, 11, 2, 2, equal 10, etc. And that comes to 69. And we're going to divide that by 15, which is the bin size. And we do that, we get 4.6. So the lower bound for the number of bins needed is 5 bins. I'm going to draw my 5 bins out. I might need 6, obviously, but I am going to need at least 5. Okay, using the first fit method, I'll put the 1 in first. That leaves 14 here. Then I'm going to put the 5 in here, leaving 9. And I'm going to put the 10 in the next one because it won't fit in this one, leaving 5. Then I'm going to put the 1 in this one because there's room, that's now got 8. Then I'm going to put the 5 in this one as well because there's room in there, that leaves 3. I've now got 11 to fit in, which I'll have to put in this one here, leaving 4 in there. A 2 will go in the first one, that leaves a 1, gap of 1. Oh, did I do that 2? Yes, that's that 2. Okay, this 2 will have to go in the second one, leaving a gap of 3. The 10 will have to go in this one, leaving 5. The 1 can go in this one here, this one's now full. The 5 can go in this one's now full. Couldn't go in either of the other 2. The 9 will have to go in a new one, leaving a 6 gap there. The 1 can go in this second one, leaving a gap of 2. Last one, 6. Well, it can't go in the first of the 3 4 bins. It's going to have to go in that last bin at the end. That one's now full. There we go. Okay, we're trying to locate Spencer in this list. The list is in order, so that's good. That's the first thing we need. So we number down the side, then get going on the binary search. So 1 add 13 divided by 2 is 7, which is Nutter. We're looking for Spencer, so we reject Nutter and above. So that's all of these now rejected. So the sublist is now 8 add 13 over 2, which is complicated. Don't actually trust myself to do anything involving adding at all. 10.5. So that rounds up to 11. We always round up. 11 is vowels, and we want Spencer. So we're going to reject vowels and below as well. So that's all of them rejected. So the sublist is now 8, 9, 10. 8 plus 10 over 2. I can actually do that one in my head. 9, which is Spencer. So Spencer has been found. Okay, next question. So we're going to do a bubble sort, and we're going to go in descending order, which means that small things are going to go this way. So 56 is smaller than lots of other things, but it can only get as far as this, because then it gets blocked by 33, which is smaller. So the 84 moves out of the way. Now the 33 is actually smaller than everything else, so it can go all the way to the end, and it's now fixed. Everything else moved left out the way. 43, 50, everything moving left out the way of the 33. Okay, 84 can't move because it's next to something smaller already. 56 is smaller than 95, but not smaller than 43, so it gets trapped by the 43. 95 moves out the way for the 56. The 43 can go past the 50, 50 moves out the way, and the 43 is now fixed. The 84 can move past the 95 because it's smaller. The 95 moves out the way, but the 84 is blocked by the 56. The 56 can't move past the 50, and the 50 is now fixed. The 95 now can't move because it's not smaller than the 84. The 84 can't move because it's not smaller than 56. The 56 is now fixed, and furthermore, we did a full pass with no swaps. So the sort must be complete. Okay, next question. Quick sort, much, much quicker. Okay, the middle is 98, so pivot the middle. Which things are smaller than 98? All of these things here are smaller than 98, so we write them down without changing their order. 68, 82, 93. Then we have the 98, which is now fixed. And then the things we didn't underline, 111, 103, and 115. We've got two sublists. The pivot for the one on the right is 103. The pivot for the one on the left, the sublist on the left, is 68. Less than 68, there isn't anything. So that goes here, fixed, and then all the other things without the order changed. Less than 103, again, isn't anything. So that goes here, and then the other things without the order changed. So we've got two sublists. Excuse me. The sublist on the right, the pivot is 115, because if there's 2 in the middle, we go to the right. And the sublist on the left, there's 2, and we go to the right, so the pivot's 82. So we've got one thing less than 82, which is 81. That goes here, and then 82, which is now fixed. And then the other thing, oh my goodness, 77 is also less, in fact, than 81. Just did that deliberately to show you what can go wrong. So, less than 81, less than 82 is 81 and 77. So they go here in that order, then the 82, which is now fixed, and then the 93. And on the right-hand side, 111 is less than 115, so that goes on the left, then the 115, which is now fixed. Now we've now got 3 sublists, 1, 2, 3 sublists, but 2 of those sublists have got a length of 1. And if you remember, when you've got a length of, oops, I've rubbed out too much. When you've got a length of 1, you can fix it immediately. So this sublist is length 1, so it's fixed. This sublist is length 1, so it's fixed. This sublist is still length 2, so we need to get a pivot and do the usual stuff. So the pivot is the one to the right. 77 is smaller. That's the only one smaller. 77 goes on the left. 81 goes on the right and is now fixed. 77 is now a sublist of 1. So that one's now fixed. So the list in order: 68, 77, 81, 82, 93, 98, 103, 111 and 115. And then we must remember sort complete. Okay, flowchart. So we're going to start the flowchart being told that A is 4 and B is 14, and we record that in the table. And we're now told that I is 1, so we record that in the table. Following the flowchart down, is A times I, so at the moment that's 4 times 1, is that bigger than 14? No, it's not. So the flowchart says that we have to increase I by 1 and follow it back round. Now, is 4 times 2 bigger than 14? No, so we have to follow it back round and increase I to 3. Is 4 times 3 bigger than 14? No, go round again, increase I to 4. Is 4 times 4 bigger than 14? Yes, it is. Now when we get to the yes, we are looking at this instruction which says that R is B minus A times I minus 1. I think is what that says. So in our case, we've got 14 minus 4 times 4 minus 1, which is 14 minus 12, which is 2. So R is 2, and then our output is R. So our final output is just the number 2. And did it ask us to explain? Yes, explain what it does. So what it's doing is taking out whole amounts of 4 from 14 and seeing what's left over. So it's finding the remainder. So if we started with a different A and a different B, it would find the remainder when we divide B by A, basically. Okay, Kruskals. So we start Kruskals by getting all of the arcs in order. So the smallest arc here is BE, 4. No, that's not an E. BE, 4. And then we've got 5, so CB, 5. And then we've got 6, DE, 6. And we've got 6.5 CE, 6.5. We've got 7 AC, 7. We've got 9 DC, 9. And we've got a 10 AB, 10, and an 11 AD, 11. And now we can start just adding and rejecting. So let's add in BE straight away. Put my dots here so I can track what's going on. D, C, E. What have I added? BE. That's now added. CB I can also add. That's not going to be a problem. DE I can also add DE. That's not a problem. C to E I don't want to add because that will make a cycle. A to C I can add. And I've now got my complete spanning tree. All the nodes are in and it is a tree, so I've got my spanning tree. So the weight of that would be the total weight, not that it asked for it, but is 4 add 5 add 6 add 7 equals whatever it equals. Okay, prims now, starting at B. So we're going to bring in one node at a time. So I'm going to bring in, cheapest one I can see that I can bring in is F. So that would cost 8. That's bringing F in. Now I will bring in C. I think that's the cheapest one I can get in at the moment, C. So C by joining it to B, that's length 9. Okay, I've got A, D and E still to bring in. I can bring in D very cheaply now by bringing it into C, that's 3. And that's D brought in. And I think the cheapest next one I can bring in is A, which I can connect into C, length 6. That's A brought in. And then finally I'll bring E in, and the cheapest way to get E in is to connect it to D, which is 7. So there is our minimum spanning tree. And there's the important bit, the order in which we chose the arcs. Okay, and finally, the nice control. We're going to start at B for this. So we're going to start at B, top, remove the row. We're going to look down and circle the smallest, which is a 2. And we're going to quickly remember to write down now the list, DB, 2, that's been added. So D got added second. We can remove D now. Circle the smallest, looking down B, I've got a 7, a 4 and a 7. Looking down D, I've got a 5, a 6 and a 3. So 3 is the smallest. Remembering to write down the list, FD 3. That brought in F, that's my third node to be brought in. So I can remove the row F. Now looking down B, I've got a 7 and a 4. D, I've got a 5 and a 6. F, I've got an 11, so the smallest is 4. So that brings a CB in, add that to my list, 4. That means I've brought C in next, that's C brought in 4th. I can remove the row, having written on the top of it. And now looking down all 4 of my rows, I've got a 7 under B, a 3 and a 9 under C, a 6 under D, and 11 under F. So smallest is this 3 AC. So AC 3. Where have I got to? That was the list, so top. So I just brought in A. So A came in 5th, and now I remove the row A, and I look down all of my rows to see how I can bring in E the most cheaply. And the smallest I can find is a 6. So that's E brought into D, that's 6. E got brought in last, which is 6th. Remove the row E, and we're all done.